Hey there, Mr. Bohr here with week 3, 8th grade science online lesson. Last week we ended up talking about the structure of the atom, how the atom's composed of subatomic particles, the proton, the neutron, electron. We looked at how to be able to figure out how many protons, how many neutrons, and how many electrons there are inside of the atom. If you remember from our lesson week 1, we talked about different models that existed. How Thomson was the first to come up with the electron, and then Rutherford's model, which is the nuclear model. We talked a little bit about Bohr and the more quantum mechanical model that we will find out in this lesson, which is more a better representation of what the atom is really doing. Start off with today's lesson being the Bohr model. And then we'll have another video segment on how to draw and what are electron configurations. So if we look at Bohr's model of the atom, basically looked at the electrons, not changing anything from what we did last week. The number of electrons is still the same, but where they exist does change. So what Bohr was able to come up with and what he focused on was the arrangement of the electrons and how the electrons actually orbit around the nucleus like planets around the sun. So they have different orbits that they would follow along. Now, what we do give Bohr credit with is the fact that he came up with these energy levels and the fact that they're not all just haphazard going around the nucleus, that they do exist in energy levels. But we do find out as Bohr went along, they don't really follow that nice planetary model that they do. But it is good because it's a visual model that we're able to see, as you can see here, how you have the nucleus, electrons moving around the outside is we would show orbits moving around the sun. The difference is we'll find out later that it's more of a probability of finding the electron. But Bohr's model is very good because it's a visual model. Later on, we'll get into the electron cloud model, or we call it quantum mechanical model that you get to. It eventually replaces Bohr's model. That's the next video segment. All right, looking at the Bohr model, how we're going to be able to draw, the first thing we want to be able to do is be able to look at the periodic table and figure out that the horizontal rows are called periods. And each row that we have, each period, is how many energy levels or rings that we're going to build around the nucleus, orbits, as you want to look at the Bohr model. The number of ring decreases as you move down the periodic table. So, for example, sodium and magnesium, as we said there in the third row, so they both have 3 rings in the Bohr model. So the rows as we go across, looking at the number of electrons, and a Bohr model works really good for the first couple of elements, but the first row has 2 electrons that can fit into it. The second ring or row that you ends up having 8, third row 8, and then you can eventually get to 18. Notice these ones down in the middle are the ones that kind of throw everything off. Those are called transition metals, and we don't get to them until we get to high school. The actual number of electrons that can fit in each ring is based off of this chart. Ring 1 still had 2. Ring 2 or level 2 still has 8. It's not till ring 3 that we get 18. So that's where Bohr was a little bit wrong on his visualization of what the atom actually looked at. He does have the correct number of electrons. It goes 2, 8, 18, 32. We find that with the electron configuration. Where they exactly exist is where he was a little bit off. So if we look at examples that we were able to have, that you would have hydrogen only having, we put the nucleus right in the middle, and we'd have 1 ring around it. Where lithium, because it's in row 2, back, lithium here, hydrogen being row 1, lithium being row 2, and sodium being row 3, tells us the number of rings that you have. So hydrogen is 1, lithium 2, and sodium 3.